Okay, tonight's title is Methods for Reviewing Weight Report, and it's a dry topic, and I make no apologies for that because it's an essential part of the project and one that we've traditionally got wrong. Fortunately, the AWD project was one of the few that actually got it right on the button. As for myself, David Whittaker, I was Principal Naval Architect for the Award Fair Destroyer in the Alliance when this paper was written. That project's now finished, and is the nature of ASC and BAE. Once the project's finished, you move on. I'm still with BAE though. Okay, so just a sec. Where's my clicker gone? Okay, well, that gets it. So why are we interested in the weight report? Well, basically, we don't want headlines like this. This wasn't the only article at the time, but my career dates back to the 1980s because Cockatoo was hoping to get this contract, and QEA did. Now, basically, the weight of a vessel is something that the general public can easily understand, which means journalists can understand it. And having a vessel overweight is basically a license to have your competence and the competence of your team and your organisation, and frankly of the industry as well, analysed in editorials. Now, being 20 tonnes overweight, as was described in this article, wouldn't have been such a bad thing, except the patrol boat only weighed 200 tonnes. So it wasn't a brilliant idea. Okay. So we can't be too hard on ourselves. Our industry is not the only one that has the problems. Navantia with the S80 plus submarine basically built a submarine, or designed a submarine that could sink, but had the challenge of getting up. It was too heavy, and the sort of articles that provoked was a decimal place was in the wrong spot and no one bothered to check the calcs. That may or may not be true, I suspect not, but that's the sort of journalism you invite when you get the weight wrong on the vessel. Now, that's the Spanish. We would assume the Germans could do better. They have a reputation of BMWs and Mercedes as opposed to Seats. But the Deutsche Marine with their F-125 vessel, okay, the vessel was built, passed to the German Navy, the Deutsche Marine, who did not accept the vessel, would not commission it, and handed it back. It not only was overweight, product of scope creep, but it had an embarrassing list of starboard, and in the confidence of modern technology, CAD tools, all these fancy design tools, it had apparently been decided that the class would have been built in parallel. So it wasn't a case of the first of class having a problem that's then fixed on the subsequent vessels. It was a case of, oh no, they're all got the problem. So we shouldn't be too harsh on ourselves. Mistakes do get made. So the Fremantle patrol boat was an embarrassment for the Navy. So how does the Navy deal with avoiding this sort of embarrassment? We have a weight monitoring program. I assume they went back before the Fremantle, but they certainly have applied to every project I've dealt with since. The RAN almost always sticks with pre-existing overseas source design. So there's proven design, which means by definition an overseas design. And consequence of the Navy's aversion for risk, the local industry is locked out of the design process. There's rumours of that changing with the new BAE contract, but we'll see if that's happened. But certainly BAE seem to be making an honest effort. The hassle with the proven designs, it doesn't provide the security to the customer he would like, because the RAN invariably changes that design. And this is not incompetence on the Navy's part. They do make variations to the design out of necessity. The Australian coastline, from memory, is about 14,000 kilometres. So a lap of Australia is longer than a trip to Shanghai or Seattle, with almost as fewer stops if you get into trouble along the way. So our ships have a different requirement for endurance and damage and hardiness and so forth than most navies would expect. Okay, we've got a weight report. Here's some typical ones. ANZAC weight report, 76 pages. ANZAC 284 pages. If you do a printout of the FFG weight report, it comes out to 1,500 pages. What I'm trying to say here is that they're big documents. The calculations aren't complicated, but they are large. And the large volume of data creates problems, A, for creating the things in terms of accuracy, making sure there's no mistakes, but also at our industry's end when we're asked to check the thing. So there's no value simply saying that there's so large is going to be an error and just throwing it back on the design team. We're giving no feedback that way, and we're just being precious. But also, we can't say that it's been produced by a reputable designer, although it came from overseas, it should be correct. Well, that doesn't cut it too, as the Fremantle and many other projects for our Navy have shown. Okay, the weight monitoring process. So we get a pre-existing design, it's fairly typical, it's purchased, and the design's weight report is submitted. Okay, now, and the specified intervals, he updates the report. Why is he doing that? Well, as I said before, typically we get a design and then we request changes as part of that design. So the initial submitted report will be the pre-existing design's weight report plus estimates for the Navy's requested changes. But just because the Navy asks for a set of changes up front doesn't mean they stop asking. And typically they will be asking for changes to the design of the ship until after it's launched. And at some point we need to be able to say no. And we need to be able to say no for fairly objective reasons. And one of the best reasons is basically, if we keep doing these changes, we won't all finish the ship and we'll run out of water to hold it up. Or to be more honest, you reach a point where the overboard discharge is getting perilously close to the waterline. Okay, so the revised reports are monitored to ensure the requested changes are not having an adverse effect on the vessel's performance. Okay, so in our case, Navantia did the initial report and included the pre-existing design plus estimates for the RAN required variations. Navantia delivered the revised weight report, in their case every quarter, and yours truly had to check it on behalf of the Commonwealth. Okay, the risks associated with this process is it's very heavily dependent on the initial weight report. Now, we assume because there's a proven design that that actual weight report is going to be correct. Well, that is a very naive assumption. All that provides us is with a guarantee that the final answer on the weight report will be correct. It doesn't protect us that when that ship was built, the proven ship was built and then put in the water and it had its inclining experiment, that they didn't detect all sorts of errors, have now corrected for it with a whole pile of single or multiple entries that bring the ship from what it was supposed to be to what it is. In which case, the contents of the weight report can be in error even when the final answer is not. The other risk is the lag between the approval process and the designs being detailed. So you're constantly monitoring, have the approved changes actually been reflected with estimates in the new weight report, and have the previously approved design changes now matured and having those estimates updated to actually calculated values in the weight report. And we're also dependent on how much visibility the reviewer and the design team's own weight report author actually have of all the changes going on. They can go thick and fast. And above all, we're at risk of an over-reliance on the inclining experiment. Once the inclining experiment's occurred, basically the vessel's already built and it's too late to fix the problem. Also, the vessel's launched, so whatever errors have occurred in public. Now, without labouring the point, it doesn't require a particularly high level of heel to create an unfortunate photo opportunity for the press. The mast is quite high, and if you're standing at the right position, when you have float off and it's just kicking over to one side, it can look embarrassing, even when it's perfectly reasonable heel. Fortunately, we don't have too many disasters, so but you do occasionally, if you lose control of the weight and the design growth on the project, you can have a disaster. The Vasa, I think from memory, was about the 1600s. Yeah, 1628. Design change during the build. The king wanted extra cannons and they had to be added high. He wanted a powerful ship. Perfectly reasonable thing for a monarch to want. Except the designer had died during the project. So that didn't help matters. They did a primitive version of an inclining experiment that indicated a problem. And they were taking it down to the next wharf to get that sorted when a small gust came up, and basically she'd only travelled 1.3 kilometres when she rolled over and sank. Okay, but what of more practical terms, what are we concerned about? Well, one thing we don't like is basically having our project on front page news of the daily for the national capital. It's not a good look. Now, we have a problem that other industries don't. If overseas industries make mistakes, typically their governments and their communities and their populations go back and keep doing it until you get it right. For us, we are likely to have a project shut down and our industry closed down. Not that many years, about 6 years prior to the Fremantle incident, you had the DDLs and HMAS Protector. Protector was shut down after the contract was awarded and the steel had already been ordered. The DDLs were an Indigenous design. I think the last serious attempt at one for a ship so capable. There was a change of government who wanted to spend the money elsewhere, and they basically used the scope creep as justification that we couldn't build ships and it wasn't worth the risk. And when there was a more sympathetic government, time had moved on. Okay, so the challenge, as mentioned before, the weight report is long and checking it's tedious. Basically, it is as entertaining as reading a phone book. And the prose is much the same. The report requires accurate data from all sorts of groups, because typically it's the author of it is compiling the data to complete the thing. The data report comes with different levels of accuracy. The report at best is a summary, and it's often a summary of other summaries collated together. Okay, so what's more of the problem? The accuracy of the weight report in a proven design. Okay, we've already mentioned the risk of the contents being not accurate. Various problems of developing the weight report because it's long and tedious, and we'll skip over that one. So we're more interested in reviewing the weight report. So we want to confirm that the changes that have been agreed are actually making their way into the weight report. Certainly the hint at the Fremantle fiasco was that after having designed a vessel, the designers weren't that keen in actually going back and updating the weight report to reflect the changes for the current contract. Okay, so you've got to check for that. Confirm the changes requested by the Navy are not going to undermine. Okay, it's one thing to know what it is and review the history of what changes have gone in, but you've got to project forward to see what more changes can actually go in and what impact that's going to have on the vessel's performance. Okay, so you've got to anticipate and identify early the impact of change. You've got to be able to tell the project when it's time to stop accepting these changes or where we're going to have to prioritize these changes. Okay, so the Navy is a multi-headed monster. There are those in the Navy who like lots of guns and those in the Navy who like lots of aircraft, and both sides like the best possible accommodation. So if you let the Navy go unfettered, you end up with something which starts off as a destroyer and finishes up with a dreadnought battleship at the front end, an aircraft carrier at the back end, and a cruise liner in the middle, sort of like the Kiev class aircraft carriers of the Soviet Union, but with somewhat better accommodation. You've got to keep them in check. Okay, so the report is long and the time is limited. And the reviewer, like the design person generating the weight report, has a management he has to answer to. Now, the nature of management is that you're likely to have your management come from different industries and not understand why you are actually going to the effort of reviewing the weight report and spending so much time in it. Also, there's a question of motivation. Management changeover. The AWD, for my period on the contract, was 10 years. You can have 3 managers over that time, basically hoping to use their performance in the current job to get a better one elsewhere. So having someone spending too many hours on the weight report is not a good look for them. Also, typically, it's not a job you give someone because you like them. So you either get a junior person doing it who's trying to do their best, but really has no experience, or if it's an older naval architect, it's usually because they're considered a quiet personality and the hope is they can do a tick and flick and make the task go away. Okay, report is long. Okay, we've already covered that. Okay, so we've got an AWD weight report and we've got to check it. We've got an initial report at BDR. How on earth are we going to get some objective evidence to say, I'm comfortable with this? Well, the first one is, okay, is the answer plausible? Is the weight given? And if we go back to Naval Architecture 101, we get some data from other ships. In this case, I basically gathered all the data I could from Wikipedia and the Navy's own website for every combatant they'd ever have, all 26 of them, dating back from, I think, 1910 when they first had a Navy, and saw where the AWD sat on the graph. And it sits on the graph quite nicely. We're plotting length versus displacement. It follows a nice cubic, goes through 0. Okay, so it's not making us feeling super fantastic about the report, but it's not discouraging us either. So we've got our first nebulous level of confidence with the whole thing. Okay, so the limitation of the overall check. Well, it says the answer's okay, the final answer at the end, but it's not telling us whether the contents of the weight report is actually correct. And this is important because as we do changes, we're going to deduct things out of that pre-existing weight report to add new bits in, the old equipment being deducted. Now, if the entries for the previous equipment is wrong, then what we add in, the combined calculation, is still going to be wrong. And so we'll have changes, error upon error. So we still require a certain amount of rigor on reviewing the weight report and the pre-existing. So how do we do that? Okay, back to Naval Architecture 101, we look up the breakup of the weight. Now, fortunately, we have this wonderful SWBS system, which so far, no geniuses in the Navy have yet managed to change us across to something nasty like S1000D, just for the fun of it. And we can use the SWBS breakup and see how that is consistent. Okay, so typically, there's the breakup for the AWD, 48% steelwork. Lo and behold, that's within about 0.5% of ANZAC and FFG for the proportion. So we're reasonably comfortable. One I will draw your attention to is the electrical plan. Now, the electrical guys, they provide the data for the weight report. They make their contribution honestly enough, but generally I'm yet to see a Sparky who has the same buy-in for the importance of the weight of their equipment that, say, the mechanical guys do. It's just the nature of their discipline. Okay, the SWBS system, if you haven't dealt with it, it's ABR 5518. It's identical for all intents and purposes for the one in the US Navy, and they have an expanded version, which is a 5-digit one as well. Okay. But the beauty of it is it's like the Dewey Decimal Number system in the library. You go to 510 in any library in the country, and you can get the maths textbooks. You go to 510 for any set of drawings for a warship design of the system, and you get the hair conditioning. It provides a certain amount of consistency so you can compare apples against apples across projects, and that is important. Okay, so let's look up the breakup for the AWD. We've now done a pie chart as a histogram, and now we can compare it with the ANZACs and the FFGs. And we look at this breakup, and it's roughly consistent. So that gives us another level of confidence. It doesn't prove too much, but our confidence level is starting to creep up. We're getting happier about the whole thing. Okay. Now, that breakup that we did before, I got those numbers courtesy of having access to the FFG and the ANZAC weight reports. Now, to be blunt, it took me 4 years to get permission to have access to the FFG weight report and use it for my project. ANZAC, it took 4 years to get the SPO to admit that they actually had it. Apparently, the person who knew where it was on leave or on contract or retired or something. And it was another 2 years after that before our computer system was security cleared enough so I could actually have it on my computer as opposed to having to go to the secret room to actually look at it. Now, if we are going to get the weight reports right, we have to have access to this data at the projects so we can do the comparisons. Now, the Navy traditionally does not do that. The FFG, so an interesting anecdote, took me about 3 or 4 years to get the letter through to leave the country to request US State Department for permission to use the data that we had for the FFGs on my project. It took the US State Department 3 weeks to write back and say, yeah, go for it. So we're getting a bit precious with the data. We've got historical data. Let's use this stuff so we can get our projects right. Okay, the other way of getting those data, that information, if you haven't got historical data, is the Weight Engineer's Handbook. Okay, that comes from a good society. It's a good reference if you're doing this sort of thing. However, chances are the person who did the preliminary design for the ship you're checking and its weight report use those formulas to get his initial estimates. So if you go down that way, instead of historical data, all you're doing is checking his arithmetic because you're going down the same path. You're not using it for comparison. Okay, the next thing we've got to do is, okay, the breakup looks okay, the total weight looks okay, but is this because the guesstimates were shrewd, or is it because someone's actually done a calculation? So we need to know to get our next level of confidence, how much of the calculation is actually as a result of someone actually sitting down and doing the hard grunt of the calculations. Okay, for this, we pick up a few tricks from forensic accounting, well, actually financial auditing. In an audit situation, this would be called an invoice test. We look at the number of entries against the SWBS numbers. Are there multiple entries? Well, yes, there are. That's good. However, when we look at this level of breakdown at the hundreds level, we find that there's basically there's no consistency. It's all over the place. That's because the data being collated and coming in as summaries, the different disciplines and different projects use different level of summaries. If it was all done by the one person using the same level of granularity, it would cancel each other out and the curves would look similar. Okay, so that's what I've described on that slide. Okay, but if we go down a level, all of a sudden, this comparing the number of entries by SWBS in the weight report suddenly comes good. So basically, this is the steelwork SWBS down to the tens level. Chances are all that data was prepared for each of those projects by the same squad, so it would have the same level of granularity across the project, so that any difference in summary level would cancel each other out. And lo and behold, it looks roughly right. It's not perfect, but we've got some level of confidence. Regardless of the class of ship, you're getting a lot more entries for foundations. That's what we'd expect. However, we're getting, say, for the Anzac, some interesting phenomena. Hull and decks, well, there's no entries there. Platforms, no entries. Bulkheads, no entries. This raised suspicion. Now, it's up to the reviewer as to whether or not he rejects it, but certainly with that data, I would be asking questions. You know, we've got no entries. You know, I can count the bulkheads. Why haven't we got a mass for them? It turns out that basically they're grouped together on the Anzac project, it seems, because of an unusual mass for 110 in that group there. Okay, that's sort of cool. But there are entries, I think, again, for Anzac, where we've got a negative weight. Again, if you don't do these checks, you don't see it. I mean, there's a lot of pages, so you actually got to have some way of interacting it, relating to the document, so you're actually getting this data. So we have got grounds for asking a few serious questions. And so the check actually tells us what's likely to be missed from the weight report, which is one of the possible sources of error. Okay, what do we do if we suspect an error? We ask questions. And the more precise the questions we ask, the more valuable and useful the question is, because now we're starting to provide feedback rather than just simply bagging out the design team. So what are the potential sources of error? Okay, as hence mentioned with the bulkheads on the Anzac, something might have been left out or miscategorized. The other one is, okay, they stuck with the estimates and didn't actually go back and refine the estimates with the calculated error, otherwise known as near enough is good enough. Then you've got the copy and paste error. This is where a system is used, or the same system was used in a different class of ship and they've just copied it over. And what you're looking for there is, well, did they remember that we had 4 items of this equipment, whereas the other ship only has 3? Did they update it for our design? And you're looking for that error. Now, this is a serious error. Someone basically made stuff up. That is, you've got guesstimates. Someone has a rough idea what the answers should be and basically threw in a pile of numbers so that the report looked right. Well, that's nice, but it's absolutely lethal for the project. But oddly enough, there is the mathematics available, and we did use it for detecting this kind of error. And it comes, again, it's a trick that comes from forensic accounting. And then finally, arithmetic errors. There are things like the last digit check where you can check the weight report's arithmetic, but you don't want to do that for the whole report. You want to use these other methods so that you can hone in on the specific areas of concern. Okay, so the strategies for finding these errors. Okay, we compare the portions of mass, which we've just seen the previous histograms. We compare the number of entries, we've seen that histogram. Okay, now we deal with another trick from accounting, and that is the reconciliation. So reconciliation is where you weigh one pile of data and compare it with an overlapping pile of data. So the first reconciliation is against the SWBS system. Now we've already done that when we did the histograms. You know, and saw that the entries had masses and there was actually a certain number of entries for each SWBS number. That is an important check. So for instance, you don't want, you'll do it against the entire SWBS system, and you'll pick up things such as if a SWBS number has an entry when it shouldn't. Now, if, for instance, you've got a surface combatant and there's an entry for periscopes, you might legitimately ask questions about that. It's an obvious error, you picked it up, fair enough. And there may plausibly be a sensible error. One of the two ships we compared, and I won't show you which one, had a kilogram devoted for atomic power on it that was picked up by doing that check. It wasn't the AWD, by the way. We were fairly clean. But a really powerful one, reconciliation we did was reconciling the weight report against the drawing index. Now for this, you need access to the document management system in a particular way. And unfortunately, it's the nature of these projects that, of course, the document management system set up early in the project, which means for this country's industry, it's set up by people who come from outside the industry and don't quite appreciate it and all the tricks we want to be able to do with it. So what you want to do is pair out from the document management system all the entries that are drawing, and from the drawings, all the entries that have material lists. If a drawing has a material list, that means there's a physical thing attached to the drawing, so there should be a mass. And so you go through and compare the two lots of data. Is there a drawing with a material list that does not have an entry? If so, we've got a point for asking a question. Is there a drawing listed that's not actually on the drawing index? Indication of a copy and paste error, possibly. Okay, and we can pick these things up. The sort of errors we got from that check on the AWD project is the lead and lag on the drawing revisions. And so questions were asked, you know, is the weight report replaced based on the correct version of the drawing and the correct issue? And those issues were addressed quite promptly, but we're able to find a reconciliation that we couldn't do for the AWD project is against the compartment list. Now, for instance, the ANZAC weight report lists a compartment for each item, which means we would have been able to have a much powerful tool for checking the VCG, TCG, and LCG for the ship in the weight report. We weren't able to do it that way for the AWD, but the ANZAC had that feature, so it's possible. We need to specify that in future reports. That would also help control granularity. Now, the granularity of the report. Now, the nature of the weight report is there are items that you can't ascribe a compartment to, like the steelwork. It's the boundaries of the compartment typically, and the piping systems go through multiple. Yes, you can leave a lot of entries with that column blank, but where it's applicable, it's a very powerful tool to have in there, and allows a lot more tricks that we weren't able to do, such as comparing compartments with similar purpose and the mass per square foot of floor area, which would have been nice to do, but we couldn't do for the AWD. Okay, comparing the frequency distributions, we've covered that one. We'll go into a lot more, and that's where we pick up the guest data. And finally, the last digit check. Okay, comparing SWBS. Okay, so we go down to the individual SWBS numbers and proportions from proportion until we find something that's odd that's out. And very localized, so that we say, this is the part we've got a question about, rather than throwing up our hands and saying we don't like the report. Okay, and then we compare the mass distributions. And again, we do the invoice and down to the individual SWBS numbers so that we can find actual entries that are wrong, so we can localize which area we're going to go through in detail. Okay, here's a good one, reconciliation. ANZAC report, power service cable. We've got an awful lot of it, entries for it on the AWD, fair enough. That may be because being a more modern ship than the FFG, we may have a lot more cabling. Possibly, there may be a reasonable explanation for that. And that won't take long to find out and confirm, in which case we can move along with an increased level of confidence. But the poor old ANZAC, there's no entry there for power cabling. That may be the cause of the blip that they had on the curve, which you'll see later. Okay, and we can all do all sorts of variations on the reconciliation there. Okay, compartment list, yes, I've described that. Okay, let's dive into the frequency distributions. And this is a fun one. This is where I'm going a bit bizarre, because this is a trick lifted from forensic accounting. Now, when you've got a set of measured data as a tabulated list, the numbers tend to follow a certain frequency distribution. And it's not a flat distribution, and it's not normal distribution. It's actually log normal distribution. And log normal distributions, you've got a pile of numbers that follows that distribution, or a multiple number of those distributions. basically the first non-zero digit is more likely to be a 1 than a 9, and we'll follow that curve. Okay, so that's from forensic accounting. Does it apply to weight reports? Lo and behold, it does. And second, FFG and AWD followed it nicely. And the blip we've got on the ANZAC's curve, that's not its lack of compliance with Benford's law. If this was a financial case, we'd be looking at a fraud investigation with that sort of shape. Benford's law, you can do it for the first digit. You can do it for the first 2 digits. You can do the first however many digits you want. You can even do it for the 3rd digit by itself. That's a very powerful tool. Okay, the history of it goes back to the 1880s, in the days of calculations done by log tables. There were a mathematician and a physicist who independently discovered that the front end of the log tables was more, the pages were more delegated than the back. Okay, so compliance with Benford's law. The overall weight report complies with it. Can we take that down to individual SWBS numbers and finding out where someone's been guessing numbers? We can, sort of. What we find is, or what seems to be, is that we hit barriers such as some entries have too few numbers because Benford's law requires a fairly large data set to actually work properly. And some SWBS numbers seem to lend themselves to a normal distribution rather than a log normal distribution of numbers, and that gives a different characteristic curve. So we've got to be careful with it. But again, we're not using it for proof. We're using it to gain confidence and find specific areas of suspicion in the weight report. Okay, so where does this log normal distribution come from? If my measured data or list of data is a function of some mathematical nature and involves some multiplication, it tends to, as I add multiple signs, tends towards Benford's law and log normal distribution. So, okay, say I've got a 9-sided dice. There's the first dice, the second dice. I'm interested in the 2 values multiplied together, and lo and behold, I get more 1s than I get 9s. And that's the basis of Benford's law. Okay, and as I add more multiplication signs to the input, the closer I get from moving from flat distribution to more and more like the classic Benford's curve. What does it work in the weight report? Well, as far as I can tell, you take something like steelwork that seems to follow fairly well. Length, width, thickness, and density, that's 3 multiplications there. So the data is intrinsically, even though it's a measured value, is a function of multiplication, so it seems to comply. 634, okay, carbon, aerial density, few less multiplications inside. I'd expect it to comply a bit less. Okay, that's a 634, the deck coverings, and lo and behold, it complies a bit less. Not entirely out of it. What if it follows a normal distribution? Again, I'm sticking my neck out here because this last part doesn't come from a maths textbook. It's me trying to find an alternate method to detect normal distributions and seeing if they apply. If you get more pluses, you tend to get this first digit thing. Let's jump. Okay. So basically, more times you've got plus in the input, the more likely you tend towards the normal distribution, which you then to get these first digit frequencies. Okay, so we histogram, we'll skip over that. You offset a bit, you get that. And then the last digit tab. Okay, in theory, it shouldn't be necessary in this modern age. But if the weight report has been compiled in a spreadsheet, it's very easy to be offset in your selection. How do you detect it without redoing the calculation? Well, basically, if you just add up the last digit or the last digits to the last digits, you should have the same last digit as the correct answer. However, once you've got decimal points, you've got to be a little bit flexible a digit either side. But still, it's a powerful tool for honing in on where that error might be once you found a SWBS that you think is got a problem. Okay, details check, identifying drawings, quota weight, so forth. Okay, so hence we've got the observations. Actually, I might pause it here for questions because basically I've run out of breath and I've probably run out of everybody else's patience. Lily, do you want to put it open for questions?
There's a few questions that have come in. Jason Middleton was first in with a question. Does electrical plant general include distribution cables, e.g.
Which
power
should,
cables for Aegis?
yeah, it should. Otherwise, the power's got no way of getting there. So the ABR 5518 and its American equivalent does provide a fairly good explanation of what's supposed to be in each SWBS and what isn't. So it's a case of practices being able to stick with what's required. But yeah, the power cabling should be in 331.
Yeah, so perhaps think maybe Jason would want to come on and talk a little bit about the motive for his question, but I imagine AWD being Aegis, having more electronic stuff happening, might be reasonable that there are more electronics in the area.
Mm-hmm.
Jason,
Yeah.
did you want to unmute yourself and ask any further question, or is that okay? All right, Jason's not responding, so let's move on. Sophia asks, David, NTB had this historical data and could have shared it for your purpose. Sorry, we didn't know you required. All right, well, I guess we're all in the same game to help one another. Martin, you had a comment?
Yeah, well, Warren, that was actually, I'm logged on as my daughter's laptop, but David, yeah, look, that makes me sad when the organisation's so big that, you don't know who to ask and you get, delays of years before you get FFG ANZAC data. We've actually got a reasonable collection of weight data from ships historically. It's not great, but it's floating around. And if we had known, it could have been sent to you.
Well, that's right. It's good. And that's part of the motivation for actually putting this down as a paper and presenting it, because unless the fraternity knows what's needed, it cannot be provided.
Yeah.
And how shall I put it? A little bit of ignorance can do a lot of damage. A little bit of knowledge and goodwill can solve a myriad of problems before they ever occur.
Yeah.
Martin, you also made a comment about the German weight breakdown system being a little bit different. Did you want to?
Yeah, so look, for the ANZAC frigates, obviously a MECO 2200. The German BWD weight breakdown system is quite different from my memory, and I suspect what's happened there is, the ANZAC weight breakdown would have started off life as a MECO 200 weight breakdown in a BWB structure, and then somehow would have had to be morphed over to a SWBS breakdown or TSC breakdown, and that's maybe explains why things have just dropped off, because there was no neat transfer between their system and the ones that we've used. Is just a possibility.
No, you're bang on correct on that. Basically, the signature on the ANZAC weight report actually works with ASC these days, and I queried him, and he actually unfolded a lot of the dilemmas they had and the anguish they had. They put a lot of effort trying to get it right. Part of it was the conversion process between the two systems, so like it was a double entry. But part of preventing the difficulty with that in the future is promulgating how damn useful a standardized subject breakdown system is for getting designs right and verifying early on that everyone is actually, where the mistakes are when they do exist. There are rumours that there are areas of Canberra that want to scrub the technical subject code altogether or heavily modify it, and other sections that want to replace it with S1000D. I haven't found the correct part of it, S1000D, but it's a document created for the aircraft industry, maintenance documentation. And because it's an online document, it's an absolute monster to deal with, because it grows without being restricted by the weight of paper.
Got you, Dave. I sympathise.
Yeah. So it's also a bit of a plea is, please don't reinvent the wheel, because us here at the perimeter, you may be making our life an absolute misery when it doesn't need to be.
There's also a comment, Martin, that you'd made around the frequency distribution and last digit Did
I'm good with that. I mean, it's all a
David's
new concept from David, but I've sort of roughly got my head around it. So thanks for that.
Yeah, there's a reference on the last slide, which forensic analytics, which describes it chapter and verse. But basically, if you want to test it for yourself, get tomorrow's newspaper and look at the share prices, pick a column and count the number of ones for share prices compared to the number of nines for the first non-zero digit. And just plot 1 to 9, have the frequency. And invariably, it will follow that curve, this one here. It's quite spooky, actually. Benford, who was the second guy to discover it, tried it with all sorts of things, not just share prices, real estate prices, the number of universal constants in the physics textbook, and the number of what the value of the numbers were in these latest Reader's Digest. And it's a bizarre tool to use. Oddly enough, the Sparkies use it to digitally filter out noise on signals as well. It's got some weird applications that well over my mathematic knowledge.
Yeah, I think it's a really interesting thing there where you've picked up from another field and brought it across in a multidisciplinary way. And there's so much that we can learn from one another cross-discipline. So it's great to pick up that idea from forensic accounting. And they do have some value, some time.
Yes.
Now, Jason Middleton had another question around seaworthiness. Jason,
Oh yeah,
would you like to...
apologies. I was just fighting with the dishwasher when you threw out the question before, but I guess noting that and having spoken with Steve Tiffin before about how they broke up platform versus combat system in the early days of the air warfare destroyer, and missing things like security of thinking about the breakdown of things like even the tons of electrical cables flowing around a ship. Is that considered under electrical plant or not? And I guess following on from that, I guess as both an end user in the Navy and a project manager, but also being aware that things like our primary repair requirements list and our list of repair items is also very late, but also allowing for space and weight margins for future growth, having worked on things like ESSM Block 2, which under Phase 6 for C4000 will then add significant weight to, for instance, the BLS. How do we then, I guess, drive and standardise, as you mentioned, so with whether under the seaworthiness construct of governance and management compliance obligations and our activity controls, by taking in the float aspect of that and then the various weight margins up through NTB, are we then going to standardise where we put not only our current capabilities but future things such as unmanned vehicles, where they sit and allow for that consistency of classification within the SWBS to then allow these comparisons to be made?
Hopefully, yes, and it's a plea that we actually maintain that consistency. I mean, we can use other topic or number of systems. The CNC uses its particular one, and with a bit of cleverness, you can use the two systems across, triangulate to an error. But if we follow the SWBS, don't play with it too much, and actually simply amplify what's already there, where on the occasions where there's a bit of an ambiguity, we have an extremely powerful tool already sitting in our lap. And using it. And if we maintain that through the life of the ship, all the more so. The AWD had a couple of other advantages, and one was a decision made before I was on the project, and that was to increase the growth margin. I mean, she's got an incredibly healthy growth margin, simply by raising the minimum height of the overboard discharges to allow for future growth. And that was an incredibly competent decision. But even though we were pretty well bang on the button for the weight, it didn't stop myself even finding the occasional article in the media saying we had a weight problem on our project. Fortunately, we didn't, but we've got to be non-naive. There are forces out there who don't want us to build ships. Sometimes it's the competing out overseas. I remember tales of the French in the days of HMAS Success being very bitter and twisted that we were getting to build it in Australia instead of in France. There's a competitive thing and so forth. But the Europeans, if they make a mistake, we never hear about it. And if anyone does, they're told to go back and how big a challenge it was that they overcome this mistake. We're told we're very dumb and we shouldn't have been allowed with a piece of steel in the first place. That's a cultural thing that we have to suffer. So
Yeah, and I
it
think
holds us all to
certainly
get it right.
yeah, I think certainly this spiral development might hopefully help us out. But I know certainly from a project perspective of trying to allow for even that regular growth of 5 years, having done, for instance, Chul's capability assurance program and looking at our additional strengthening, even just for a landing craft, as we then vary that type or the amount of tanks and that sort of stuff. But no, it was very excellent presentation, and certainly it's not only this morning in our capability and technology management course, they were talking about mapping out soldier weights and stabilities, and down to that same sort of. And similarly, our Air Force brethren will be doing the same with their air vehicles, of obviously looking for these nuances in these weights, and I know that similarly Joint Strike Fighter trying to map the errors and that of their millions of lines of code, and how do you validate that? This certainly does draw out some good lessons in terms of that assurance of data, such that we can then proceed with a reasonable level of confidence, as you know, I guess as the end user being Navy and capability managers.
Correct, and you bring up a point there, and that is, how do you go about checking how to confirm this quality control? Now, on the weight, it's a particularly harsh topic, because checking the weight of the vessel is not a glamorous job, as I alluded to at the start of the presentation. You don't get the job because the boss likes you. And typically the way it's dealt with is someone in the yard will start weighing each item, seem a prudent and a reasonable strategy, but invariably that very dedicated individual will last between 6 to 18 months on the project before they find it more comfortable to work elsewhere with another employer. That's just the human dynamics of it. And as for when it's given to a junior person, if he's still doing weight control and checking the weight report 2 years after he's first given the job, he generally regards it as read that he's regarded as a bit slow, and his career is stalled permanently. So if we can overcome that by actually specifying not only that we want the weight report, some more detail on what we wanted in the weight report, but also how we intend to check the weight report, then it becomes a more serious and a more real job to management. Like one of my party tricks I like to do is, okay, I'm checking the weight report. That does not make the weight report correct, no matter how faithfully I make it correct. So I want to be able to say the weight report is okay and it's great to go, but to do that because it's correct. Well, how do I get the weight report correct as a checker? Well, I do a bit of sleight of hand and a bit of motivating. If I pick something 2/3 of the way through the weight report, where there's a drawing there that's in the weight report that shouldn't or should be there, and ask a pointed question early in the project, all of a sudden, someone's manager in Spain knows that there is someone in Australia, there's some obscure desk, who's actually reading this thing. And that changes the dynamic in Spain or wherever the design's being done. If 6 months later, I then ask a similar question from something early in the report, all of a sudden they get the message that the first 2/3 aren't necessarily correct either. And if there's any error that's there, Australia's going to find them. And all of a sudden you've got the people preparing the weight report in Spain given permission to spend some time on it. That has become a more real job because the customer is asking detailed questions about it and is asking very informed questions about it. And so you've given permission for the whole process, both ends of the project, to actually get it right. Just by, because you remember, at the poor soldier who's done the weight report, hopefully he's done it and is looking forward to getting onto something a bit more interesting for what he trained for, because he's on a low status job. He's still getting his pay, but all of a sudden there's someone's actually taking an interest in his work, probably more interest than his boss ever took in it.
Now, David, you were just sort of asking for questions midstream, right? Where you've got some more of the presentation to continue, or? Yeah,
okay. I'll go through the rest of it fairly quick. Okay. So
and we'll come back to the other questions that are outstanding.
Okay, so observation. Okay, so the lessons is like the start of the conclusion, a series of observations. Observation 1, okay, the Benford law does actually work in this situation. Okay, I've got to get on with this. Okay, 2, that it works for better for certain swimmers groups than others. So we're doing a cross comparison. Observation 3, knowing if I get to look at enough ships' weight reports, I can refine this list so I can say which swimmers groups are likely to naturally comply with Benford's laws and which are not. And that becomes an extra check in the toolkit for reviewing the weight report in itself. So if say for 550, which we think at the moment naturally does not normally comply with Benford's law, if it suddenly does on an individual weight report, well, then we've got a characteristic check and a tool to use. Observation 4. Okay, we can take this down to the level. And if we get more data and specify the granularity, we can get more data so that SWBS, the Benford's law should comply more often because we can tell it complies because we've got the data to check it. By right, you should have at least 1,000 entries. We're trying to use it in data sets of less than 100 on occasions. And still we're getting some reasonable compliance. So, okay, observation 4, we break this down into the individual SWBS numbers, and we've got a set that from a gut feel, looking at weird wiggly curves, we think certain numbers should comply with Benford's law and certain numbers should not. Observation 5, we do the same for normal distribution. We think certain SWBS numbers are more likely to comply with normal distribution than not. More likely or less likely. Okay, so we've got that, and there's a bit of overlap in the list. But again, because we've only played with this tool over 3 ships, and that for me, usually when the boss wasn't looking, because otherwise Dave Whittaker is playing with his spreadsheets again and not getting on with real work. Okay, but we have the potential for the tool here if we can invest in the time and get access to the extra data. Observation 6, I mentioned during the question time, please don't play with the SWBS system. Try and standardize it and keep it standard. Okay, so get back, we're trending towards a conclusion here. Okay, we do get compliance with Benford's law. We get shapes like this, it's suggesting normal distribution, and why that is not just a random shape is that although we've got a peak, it's building up to the peak from both sides, so that's suggesting that we're getting a first digit behavior that we'd expect for normal distribution. So we see something like this and we're saying, okay, there's a normal distribution creeping in there for one of the ships. Is it some data that shouldn't be there? So the hypothesis is that for an individual SWBS number, its compliance with Benford's law should be fairly standard from ship to ship class, if we had enough data to measure it and had a mathematical tool to measure it in. Now, the typical tools that measure compliance with curve fit are fairly primitive, typically describing what's the maximum error from one of the measured points compared to the anticipated curve. We need something. I need some maths so I can reduce compliance to an individual number, as it were, that takes into account the shape, and it's better than the tools I've found. But in theory, hypothetically, we should be able to get a characteristic level of compliance, SWBS by SWBS, for the Benford's curve, and have that as a tool for checking whether we think the data is legit or not. Okay, so comparing with historical data, yes, we need the historical data to compare with. We can do the reconciliations, and they're fairly good tools. That drawing index, Nick Clark used that at our end, and he used it to very good effect. I then took his lead on it. And it gives you a very powerful questions that are very easy to understand, even by the designer's management. I've got a drawing index here, it's got a material list. Why haven't I got a weight entry for it? The last digit we've discussed, and comparing compliance with Benford's laws. Okay, we've described a sequence in which to go so that you're not doing the detailed checks before you have to. We've already discussed that, mass of the vessel. Yes, the AWD was pretty well on the button. Future projects, taking the time of effort, can we set up these tools? And last but not least, this is the sort of thing we want to avoid because it can kill our industry. And we're a defence industry, there are forces out there that would like us not to exist without having to go down the road of conspiracy theories. But if we can be the place which checks everything and gets it right, as well as doing it in a timely fashion, well, that should help preserve our industry. And last of all, that Benford's law comes from that reference there. It's not the only reference for it. You can get it on Wikipedia and so forth, but that's a whole textbook devoted to it from Forensic Accounting. And the other good companion that I've referred to is the Society of the Weight Engineers Handbook from the Society of Allied Weight Engineers. Okay, so that's me actually finished. You guys have actually put up with me for an hour, almost an hour and a half. I congratulate you.
Oh, an hour. We started at 6:30.
Okay then.
We were chatting a little bit before that, but yeah, thanks very much, David. We'll go back to some questions. There was one asked by Jason Stewart, and I guess if I can sort of paraphrase it a little bit or make a comment around it, you know, with the idea of Industry 4.0 and, you know, the interconnectivity and the, you know, use of the digital twin, you know, those sorts of ideas. Given that you're using historical data for FFG, you know, some of the weight data going back to the 70s, you know, the ANZAC in the 80s, into the 90s, I guess, and now AWD in more recent times. Certainly there were different tools that would have been around to support the process. So, you know, if we are becoming more integrated and practicing concurrent engineering in the design processes, at least the weight estimates that are given in the design needing to be validated against actual items that go on board the ship, of course, that check needs to be made. But can you summarise what tools, you know, how much integration there was, or was it a sense that the data you're using was just developed on a spreadsheet or just a book?
My impression is that Novartia used an integrated tool. Software they tend to go for is Foran, although those of us who know Owen Hughes, they do a lot of preliminary design with Maestro actually. They were one of the big users, and I gather still are. But in terms of for the detailed design, they use Foran, and I haven't been to Spain, but those who have said there's quite an impressive setup. That said, Foran is capable of lying to you. So you just can't hit the magic eye, if you compare it on Foran or NX or CATIA and get weight. The software, it's more sophisticated, so it's more hidden as to what assumptions it's making. But certainly Foran stability calculations, NTB challenged them. And certainly I did my own personal check of the table of offsets Foran generated, and found that there was an aft portion of the vessel that didn't physically exist. That is, with the cutting and pasting of the geometry to make the hull shape. Something wasn't deleted that should have been deleted, but it didn't show up because it was past the aft end of the ship, so it didn't appear on the screen, but it was still there in the mathematics. The nature of the sophisticated tools and this integrated engineering is you really still need to do the old engineering thing, is check it for sanity. And I found the more sophisticated the tool, the more I need to actually jump back 2 levels of technology to do a sanity check to see if it isn't lying to me. HAL lies, and you've got to be prepared for that.
Yeah, fair enough. Just a request to, at least while we're chatting, put the conclusion slide back up. So if you can go back 1 or 2, I think.
Yep.
And Craig Elliott, would you like to come on and ask your questions?
Yeah, sure. G'day. Can you hear me?
Yes.
Yep. Oh, excellent. I was interested in what the original weight estimate was and what the actual displacement was and what the structural limiting displacement is, those 3 figures.
There's limits as to what I'm allowed to say in terms of getting this paper approved. What I can say is the margin for future growth is pretty close to 500 tonnes, which is incredibly generous. The ship's strength is phenomenal in spite of the cutout for the accommodation ladder near the midship section.
Yep.
That added by the fact of the quality of steel used is, how should I put it, the AWD can take a pounding far better than the Spanish sisters can. And as for the weight, how should I put it, when we picked it up on the synchro lift and weighed it, it was surprisingly accurate. That said, one of the deficiencies we have with the Industry 4.0 and the digital design is, in the old style design, we would have had an as-built table of offsets. In the digital design, it's assumed that those design, initial offsets are accurate and have been carried through. It wasn't part of the TSC to actually lift as-built table offsets. In modern photogrammetry and so forth, it's not a big job to do, but it wasn't actually part of the task. So when we do the inclining experiment and weigh the ship, we're assuming that the geometry of that ship as built actually matches what's in the table of offsets. Well, that's a very courageous decision. So by rights, getting back to the Industry 4.0, just because you've put it together like a Lego kit doesn't mean that you haven't got a ship that's 2 inches longer than its sister, or the nose is half an inch to port or starboard compared to its sister. Okay, we pick a lot of that stuff up in terms of building up the blocks, but frankly, there's a lot to be said for actually measuring it at the end of the day and making sure that the ship you were actually sold was the one that you thought you bought.
Yep.
Greg, you had some follow-on?
Sorry, a second part of the question as well. Just around weight monitoring in production, because I know there was things being weighed as low as 5 kilos, nuts and bolts, and then there was sub-assemblies being weighed at 200 kilos. But for me, one of the things that was probably pretty powerful, I don't know if it was, but it probably was blocks and sub-block weight, because that's quite a complete unit, so you probably have a fairly high confidence there. But I know at the subcontractor yards, the scope of works was constantly changing, so to get the completed weight of an advanced outfitted block was quite challenging, because it depended on how much gear was actually in there compared to what one expected, I suppose. I don't know if you've got anything to say about that, or...
Yes, I agree. And I remember Adam when he was doing that sort of stuff, and I remember how early in the project Adam disappeared because he got a lot of grief over that process. But he was following it, what he was asked to do, very faithfully and very meticulously. I don't think AWD was unique in, how should I put it, that data not being as carried on for the entire project as long as it should have. Part of it was that the nature of the data we got from Navantia. Again, selecting the data for the blocks, what was getting completed at that point in time, what fluids were in the components at that point of time. Yes, it's a challenging, I'd say at this stage, until we go for Industry 4.0, I'd say a well-nigh impossible job.
Thank you.
That's part of the reason why I went down the mathematical route.
Martin, you had some additional comments around RiverCat and an old paper.
Yes. Look, first of all, David, there is a nice old Navy Engineers Journal paper called Fundamentals of Naval Surface Ship Weight Estimating. I think you sort of alluded to using techniques like that, where you're basically scaling from a known frigate with a known weight breakdown, and then, you know, doing scaling for different weight items based on different parameters. So, you know, if the length of the shafting doubles and the power doubles, there's sort of scaling for shafting from parent ship to new design. So I guess if you had access earlier to more weight estimates of FFGs and ANZACs and the like, there might have been a hope that you could have been able to cross-check that way.
Yes, it's a two-edged sword, that methodology. One, because of the size of our Navy, we don't often have vessels of the same generation that are either side of the displacement and performance that we're interested in. So it's a very hard one for us to use unless we've basically got access to American design data from their naval program. The other part is, chances are the designer of the ship used that methodology to do his initial estimates for his initial lap of the design spiral. So if we go down the same path, we're confirming, yes, that the thing is within CUI, but we're also to some extent repeating his initial calculation and checking his arithmetic for his initial design iteration. we don't want to check his arithmetic at that stage. We want to check the plausibility of the answer. And so with the limited data we've got to use somewhat other techniques from the ships we actually do have.
Yep, it's a good point. Just with the other thing, you know, I had a quite fun job early in my career on a rotation up to NQEA, and I just, Warren noticed it. So Graham Parker, the designer of the ferries, was quite adamant that NQEA had to do weight monitoring the whole time, just to make sure that the ship that came out was consistent with his own estimates. So I was lumbered with that job, but it was a fun job. We did try and sort of measure the weight of individual modules as the ship, as those ferries were being weighed. But then you had the complexity that you had to now create a weight estimate just for a module with all the associated parts hanging off it. It was actually a bit of a tedious job. So I think you were alluding to the same sort of issue for the AWD. And I was only dealing with a little Rivercat that, you know, you could almost look at what was being weighed and try and account for it. But it was still a bugger of a job trying to make your weight estimate for that module match up with what you're actually measuring.
Very much so. It is a serious engineering task, and you're sort of going the opposite. You're not. It's like trying to guess how long is the length of string, as long as you want. But in this case, how small is the piece of string? How accurate do you want? And what you're going to. And really, one of the things that having the other weight reports allowed me is what's plausible and what's reasonable in weight reports. And you take a normal career such as yours and mine, often you only get to do this job once in your career. So how do you build up expertise if you don't have access to the other guy's output on the for the same task and build on their errors?
Yeah.
All right. Can I open the floor, or people want to put their hand up to ask other questions? Are there any other questions? I'm not seeing any hands up or anything else in the chat.
Can we see the recommendation slide again? Sorry, you skipped through them a little quick at the end.
Yes, sorry.
It was a few on from that, I think.
Am I going in the right direction? No,
other way.
That one?
Next one.
Next slide.
Okay.
Yeah, this one.
That it?
Yeah. Thanks.
Yeah, so just a comment for everyone. David has forwarded to Lily, the ACT section secretary, a copy of the paper. So if you'd like to request a copy, then if you can email Lily at the ACT section email address that you would have got advertising this technical paper presentation tonight for a copy of the paper. Any questions arising?
I guess I've got one from a user who probably brought on 200 kilos worth of gear in my esh bag, and I guess having lived through the Anzacs and seen that growth in weight, I think we added something like 200 tons or something to it by the end of the ASMD. But certainly, I think by, what would that be, 2010, I would say we were probably much more aware of weight stability and growth, and keeping track of those additional configuration changes and cumulative effect of that. Do you see there's a much more positive attitude towards weight and stability and tracking now in Navy and Defence within that as a result, and you're now leveraging that from the air warfare destroyer and others going forward, or do you do you hope that culture continues?
I hope the culture continues, and I am seeing the culture there. The fact that I was allowed to apply myself, and the others in the AW team were allowed to apply themselves to the weight question, the way we did and to the intensity that we did, I thought was remarkable. I hadn't seen that level of understanding before in my career, That said, yeah, it is a by and large a thankless job, and sometimes you basically have to preserve your job. Give the broad hint that if I'm not doing this, boss, you might have to find somebody else who will, or end up doing it yourself. In which case, they tend you to leave you alone fairly quickly because it's not a job the boss wants to be doing himself. So yeah, the attitude's there. It has changed. There's a lot more awareness of the industry, a lot more awareness and less naivety of what's required to keep the industry and keep the industry going. It's not good enough to be just as good as the designers overseas, who at the end of the day are honest Joes like ourselves trying to earn a living and try and apply themselves honestly to their profession and their country. Certainly we're no worse, but to preserve this industry, we've got to have a few extra tricks up our sleeves and apply a few extra flair points of flair that they haven't thought of. But I'd say certainly the attitude to weight is improving, and hopefully the idea of the paper was to help that along in the right direction.
So how many people were working on this in the AWD project?
Okay, so in the alliance level, we had the task of reviewing the design product, that is the ship as it was designed, not as it was built. And so reviewing the weight report at that level was myself. In the yard, you had Nick Clark and one or two others, and you had Adam, who was at the weighing in, but he disappeared early back to Queensland. So not really that many, but in terms of Nick Clark's component in the yard, and when he dived headlong into it, at various, as it was required for preparation for the inclining experiment and other bits he was dealing with, I found the best trick was, as an older naval architect, was a wander over to his boss and politely suggest that what Nick was currently doing was extremely important. So could you please give him a bit of peace and quiet while he does it, because it's going to be in an awkward situation if he gets this wrong, and it's an easy thing to get wrong. So the older voice in the boss's ear commending what a wonderful job Nick was doing in the dockyard side of things certainly seemed to not hurt Nick, and he is a very good naval architect. But yeah, there wasn't that many, and considering the number of high-powered people having high-powered meetings, the best that can be said for the AWD in that respect was we didn't have the traditional bun fights as to out of whose budget this or that weight margin was going to come out of. So we weren't wasting the man hours there. The time put in was actually put in consciously. At every management meeting, there was a KPI slide on the weight and how it was going and how we were tracking. They were keenly interested at the highest level as to how much of the margins in terms of the build margin and the design margin we were using up, and whether or not we're going to eat in the future growth margin once we handed over the ship. So they were certainly conscious of that. They wanted the data very simplified, but yes, there was consciousness of it at the highest level.
And do you think it's a function that like the naval construction branch would be good to host? Or do you think it's within the project?
I think it needs to be in both. You need an educated customer. If the customer doesn't know what to ask for, he only gets what he's asked for. Because at the production end, where a lot of it's got to occur and show up, they have to have it in the tasking to have permission to actually do it. Otherwise, you're accused of, quite rightly so, of adding to the contract what we're not being paid for. Why are you doing this? Somewhere in the customer's organisation, they're already paying for that to be done elsewhere. Why are you doing it a second time? So yes, it needs to be at both ends. There needs to be a knowledge across the board. And each part has got to know its components. And one of the things I had with the AWD project was when I was in trouble, I was actually able to phone Canberra and be quickly directed to the right person who not only could sympathise where I was going at, but also confirm that I was attacking it with no less rigour than they were. And it wasn't just me that had that interaction. So in terms of being able to work with the customer as a team, that was excellent. Being on the same page, there was awareness. The Navy needs a ship, and it needs, a ship that is capable of going into harm's way and coming back again. So there was that level of awareness. Not necessarily always on the military types, ex-military types, they tend not to think quite that far ahead. But if you explain it to them in simple terms, they do come on board.
There's a little bit of chat going on backwards and forwards from a few people. There's a little bit of a side thing around the patrol boats. Alistair's got a question though, talking about batch build processes. And Alistair, would you like to? A bit before Alistair, I just want to comment. Trevor Blakely's here from the UK. Thank you, Trevor, for joining us. And he's just made a statement asking me to remind you that the recording, the presentation and Q&A will be on the YouTube channel. And he's commented he looks forward to reading the response from the French and Spanish members of RHINA if they sit down and listen to your presentation, David. But Trevor, would you like to say a few words before I ask Alistair to pose his question?
Oh, very quick few words, David. Thank you very much indeed for that very practical and non-academic presentation, which I very much enjoyed. It brightened up a somewhat dull and wet UK morning. And before you say it's probably the same there, remember this is my summer, not my winter. Thank you very much indeed. As I said, your presentation will be put onto the YouTube channel, which has now got quite a good turn up. So it will your wise words will spread beyond the shores of Australia, I'm sure, even as far as New Zealand.
Thanks, Trevor. Alistair.
Yep, can you hear me?
Yes.
Yep.
Yeah, I guess my question was a little bit touching on what you said right near the beginning of something that we're often wary of when we take a reference ship design from another designer to question whether it's really proven or whether it's just been fudged to match the previous inclining trials. I guess taking that one step further as we're entering into continuous shipbuilding and a batch building process, have you got any thoughts or ideas around better ways to manage that feedback or correction from an inclining trial to pinpoint those uncertainties or errors to update it to improve the fidelity of the calc going forward?
Yes, basically the accuracy of the inclining depends on the accuracy of the data it uses. So when we do an inclining, we weigh the ship by basically reading the drafts and using the drafts to then get the weight from the hydrostatics. Well, that's well and good if the shape of the ship used in calculating the hydrostatics was actually the shape of the ship as it was built. You do get anomalies. So providing we actually do an as-built dimensions of the ship for each one in spite of a batch, because the big management temptation is it's exactly the same as the other. It's all this NC equipment and so forth, but we're not building Toyotas. We're building ships, and they're big things. There's, the civil engineering scale. So as built offsets for each ship, and this modern days of laser theodolites of high precision and photogrammetry and so forth, it's not a hard job just to sweep across, get both sides, and get the data for the fully assembled ship. The other one, big one, is actually doing the same for the tanks and the sounding tubes. If we don't have that corrections for the tankages correct, that throws off the accuracy of the inclining experiment, and then that throws out the accuracy of all sorts of things. That said, we did do an inclining experiment for each vessel, and although there wasn't much difference, it was surprising how much difference there was. And that's understandable, again, when you consider the scale of what we're building. It's not a big thing for a sounding tube in a tank to take a slightly different route than a sister ship. And you've actually got to go down to that level of accuracy. If we're going to go Industry 4.0, let's use it full tilt and make use of the accuracy and the knowledge it provides us of how well we know our own product. Does that sort of answer your question?
Yeah, thank you very much.
Okay.
A few more comments from different people in the chat. Craig Elliott talking about 7 to 7.5% growth margin doesn't seem that much. Wonder what the FPS was, 9 to 10% perhaps. Phil Helmore's commented, as well as it depending on sounding tubes, the accuracy of the location of the draft marks that you're actually reading.
Oh, yes.
Yeah,
and Guy Anderson is suggesting.
Oh, sorry.
Sorry, Phil. Yes, go on.
Yes, I was just going to say I can point to about 3 vessels around the Australian coast that have the draft marks on in the wrong locations, and we only sort of find that out when you come to do the inclining and you take check freeboards, and
yes,
and you find that they really don't match up. And oh well, I know 2 tugs and 1 tuna vessel that has the draft marks in the wrong locations.
Absolutely. And these mistakes are surprisingly easy to make. I mean, you've got to be honest and ask yourself, how much naval architecture do you expect the painter to actually know? If you've got an industry that's reasonably established in a community, that the knowledge permeates, what's involved in getting the draft marks right, and that he needs to have someone put some pop marks so that he gets it bang on correct. But you know, you can't assume that the poor painter who's doing his job in all good faith has actually been given the full significance of what he's been asked to do.
Well, actually, one of them that I know of was put on the draft marks were put on a slipway with a declivity. And when they were going from the tangent point, you know, at the bottom of the forefoot, the declivity of the slip was put on in the wrong direction. and so the draft marks ended up 7 inches out of location. And then on another one on a tug, we actually put pop marks on the vessel to show where the draft marks had to be. But when they came to paint them in, they painted them in 100 mil out of position.
Yes.
Between the pop marks, okay, but incorrectly. Anyway,
yes, there's a lot to be. No, it's a good point, because there's a lot to be said for the old adage: step back and take an overall look at the job before you let it go, and see if it looks right.
All right. Well, I think we're probably getting to the point where, again, just mention that the paper will be ultimately available through Lily. The recording will go up on the YouTube channel. And we get to the point of thanking David for his contribution
Could I ask
this
a question,
evening.
Mike?
Ray, yes. Yes.
I'm very interested in this top-down approach, and I'd never seen it applied in that way. But I guess you have found and highlighted some specific bottom-up issues, but where are all the lessons learned in these bottom-up issues captured so as you have confidence at the end, a little bit in the old way, from the bottom up? I guess this is a good way to get some confidence, but equally everything you find should then sort of slot its way down and change the ASC processes to both give you confidence from the bottom up at the same time.
Okay, if I can answer that in a roundabout way. The ASC AWD project did have a lessons learnt. The people who put together the lessons learnt have come from a certain perspective. That's not necessarily a naval architecture perspective. It's more of a financial management perspective. But there is an attempt to do that. And then that gets feedback to Navy. What Navy then do with it is a big challenge. It's a large organisation, and information goes in but doesn't necessarily come back out again where it needs to come. You got complicating with that is, say, for instance, for the AWD, we finished the project. I was fortunate to be there till I was told, pens down, David, you're not being sacked. We've just run out of project. You're going to have to go down to Flinders Uni for a bit until the next one needs you. And so you've now got a new management of BAE. They, in this country, have their own history and their own background. ASC, when I first started there, it was an unusual organisation because I'm used to having half the degrees on the floor of my building. ASC was different to that. Basically, I was not the only guy on my row of desks who had to give up his PhD because he got married. and had to give up his academia for love. That was fairly typical. You had a whole pile of very clever, well-educated and capable people who by and large didn't quite know what they were doing at the start. At the end of 10 years, you had a very capable, well-educated and trained set of people who knew what they did not know. If the same group of people on the same community was sent straight into the next class of ship, within 3 years of that project, you would have had a very hard to challenge group of people who were not only competent, trained, extremely bright, but extremely experienced and self-perpetuating. Whether BAE can achieve this with a change of ownership, I don't know. Certainly they seem to be trying. But that is the challenge, certainly for this industry. Typically, traditionally, naval shipbuilding in Australia occurs once a generation, about every 25 years, just when the tradesmen from the apprentices from the last build are approaching retirement, so they can train the next lot of apprentices on the next build. We're now in a different geopolitics, which I can't comment on, but there's an attempt to actually get the self-perpetuating. But I was surprised at the level of education in Adelaide, the technical expertise that was in Adelaide. It was similar to Newcastle to an extent. The only thing missing was the shipwrights. And that's a characteristic of the industry here. It's steel work and there's not much timber in Adelaide, in South Australia. But that was basic. But yeah, the expertise was growing. And so whether that translates into the next generation, we'll see.
Yeah, I guess you have certain points along the build where you can check weights, but you did say that the data didn't necessarily support you being able to validate that as you go through. And I guess it was about generating data that was useful to you to support that process and validation process as you go through bottom up, rather than top down after the fact trying to identify errors.
Yes.
So
yeah, we're trying.
Yeah, hopefully with this drip feed, even though it's a bit slow, will generate a level of consistent approaches and we can have data that we can build on as we go through.
That is correct, but it's also the responsibility of the Navy to specify what they want. And they have to be a competent customer to be able to specify it.